Today I'm going to be giving you a quick demonstration of Tightrope, a new tool we've developed at Synonym that will help you keep lightning channels in balance as part of a cluster of lightning nodes that you might be responsible for maintaining. Tightrope is designed for organizations that have a collection of lightning nodes that they need to maintain. Typically for these sort of clusters of lightning nodes, you would create high liquidity channels between them for routing purposes, and these channels ideally need to be maintained in a balanced state with half of the liquidity on each side of the channel. Tightrope helps you automate the process of keeping those internal channels balanced. So in this demonstration we have a small cluster of lightning nodes made up of three separate lightning nodes. We've got this one here called Alice, this one called Bob, and this one called Carol. And as you can see, each of them has a channel open between each of the three nodes in this network. If we click on each of these channels, you can see the channel state is currently balanced. The color scheme in this indicates where the funds are, and so half blue, half green tells you the 50-50 split of funds. So likewise with this one and this one. So just these three lightning nodes in the middle here are being managed by Tightrope. So the way Tightrope actually works is it operates a sort of distributed networking stack for connecting these peers to each other. So when it starts up, there is like a discovery phase where it first connects to each of these lightning nodes and gradually discovers all the channels that interconnect them. So over here on this side of the screen we have the logging output from this version of Tightrope that's running. So you can see at the start it connects to each of the nodes in this setup, and then gradually we see these peers connect to each other, identify each other. So here Alice and Carol have identified each other, found a channel they have in common, this channel here, and they both start watching this channel. And the idea here is that it will continue to watch these channels, and any time they go out of balance, it will take the appropriate action to put them back in balance. So this continues down here where Bob and Carol find each other and Alice and Carol find each other, and all those channels are start being watched. Now, because this is dynamic, we could add new channels and Tightrope would automatically discover those, and we can also add new lightning nodes to the network, and those peers would all automatically be rediscovered on the fly. So there's no need to change anything for that discovery to happen. In this case, all three of these lightning nodes are operated by a single organization, which is me, and so that they can all be operated from a single instance of Tightrope. Tightrope does also support more fragmented distributed setups, so individuals can operate Tightrope, and they can be configured in such a way that there's automatic peer discovery of other parties in a collective that want to maintain liquidity between their channels. So it's quite flexible from that point of view. So I've zoomed out a bit on this development lightning network that I've got here. So you can still see the three nodes in the middle, Alice, Bob and Carol, which are being managed by Tightrope, and there's these three other nodes at the edges that have open channels to one of the nodes in the network. So we're going to make a payment that will go between two of these external nodes, and will pass through our network, affecting the liquidity within our network. And over here in the logging, you should see Tightrope noticing one of the channels that it is watching going out of balance and taking the action to put it back in balance. So first of all, let's create an invoice over here, and then we will get Frank to pay it, like so. Okay, so that payment is completed. It went from Frank through Bob, through Carol, and over to Erin. And you can see this channel in the middle here became out of balance. So Polar here, which I'm using to visualize this network, doesn't notice that external change to the channel, so it's still showing as out of balance. So I'll need to refresh that. So if we refresh the view here, you'll see that it's already pushed this channel back into balance. So if we go over to the logging over here, let's go back to where this started. Okay, here we go. So Bob is realizing that he doesn't have enough funds on his side of the channel, so he's creating an invoice, making a request to Carol to pay that invoice, and Carol is then paying that invoice and putting the channel back in balance. Now this communication happens over a peer-to-peer encrypted network, so this can happen independently of where the actual Lightning nodes are being maintained, so the infrastructure can be separate if necessary, as long as they have API access to the Lightning node. The changes will be able to be made. So all of this information, this log you can see here, plus all the transaction history, is recorded in append-only logs that can be shared if necessary. That they are also available inside this distributed peer-to-peer network. So that shows a single transaction being rebalanced. The balancing process has quite a lot of control over it, so you can configure how far it has to get out of balance before a channel will be rebalanced, how often it will check. You can also, in this demonstration, we've always used a 50-50 split of the liquidity on a channel, but that split can actually be configured to be anywhere. So that is a brief summary of the initial sort of functionality that you can expect from Tightrope.